Good day everyone. So for this video we will talk about limits and continuities part 2. This is a continuation of the discussion that we have had last time on the limits and continuities. For this video we will go on the in-depth discussion on how to get the limits of a function who tends to form an indeterminate form of their limits respectively as x or as an independent variable approaches to a certain finite value. So the last time we determine limits, we mostly come with a finite number, and those are real numbers. We might have evaluated a limit that does not exist, basically for functions that are for radical functions. So if they are imaginary, then the limit does not exist. So for this video we will talk this what will you learn for this video. So basically you will learn indeterminate forms, the methods on finding the limits of indeterminate functions that will form indeterminate functions, indeterminate forms of limits. So we have the factor and cancel method, the method of rationalizing, the combining fractions and logarithm, the basic trigonometric limits and other transcendental limits, and the limits for parametric and polar curves. So this will be discussed thoroughly in this video. Now we will go to indeterminate forms. So these forms here are indeterminate forms. 0 over 0, okay, so infinity minus infinity, infinity raised to 0, 0 raised to 0, infinity over infinity, 0 times infinity, 1 raised to infinity. So these are some of the indeterminate forms that you might encounter in differential calculus. So we have this definition: a function y is equal to f of x has an indeterminate form at x is equal to c, where c can be finite or infinite if first f of x is continuous on an interval including c except possibly at c, and the second, when we try to evaluate f of x at c, we obtain one of the following forms, so those that I have mentioned a while ago. So notice here that 0 and 1 represent variable quantities approaching that value, so it is not necessarily 0 and 1. They are not exact, they do not have an exact value, but they are variable quantities approaching to that specific value. For example, point 0001, point negative 0.0001, 0.99999, they approach 1 and they approach 0 respectively. So they are not constants with that exact value. So to resolve an indeterminate form, we will discuss here. So we need to use appropriate methods to determine if the limit exists, and if so, what its value is. Now, remember always that even though the goal of a limit is to determine the behavior of a function near a certain value, the first step in computing a limit should always be to determine what form the function takes at that value. So we will discuss first the first form of the first indeterminate form, 0 over 0. The form 0 over 0 is indeterminate because it represents the limit of a ratio of two very small quantities. So this ratio can approach any limit depending on the relative size of the two quantities. So they cannot be determined because, for example, hindi natin alam kung yung 0 sa taas is malaki ba, mas malaki ba sa 0 sa baba. They approach a certain quantity that we do not know. Also, the 0 times infinity, this form is indeterminate because it represents the limit of the product of a very large number and a very small quantity. So we do not know their product. So this product can approach any limit depending on the relative size of the two quantities. So this is considered to be an indeterminate form. Don't be confused. A 0 times a number according to algebra is always equal to 0. But here in differential calculus, 0 is not an exact number, but it is a limit. It approaches to 0. So 0 times infinity is one form of indeterminate number. Next, infinity over infinity. This form is indeterminate because it represents the limit of the ratio of two very large quantities. So this ratio can approach any limit depending on the size of the two quantities. Next, we have infinity minus infinity. Infinity minus infinity. So this form, infinity minus infinity, is indeterminate because it represents the limit of the difference between two very large quantities. So this difference can approach any limit depending on the relative size of the two quantities. Okay, next one is 1 raised to infinity. The form 1 raised to infinity is indeterminate because it represents the limit obtained by raising a quantity close to 1 to a large exponent. Since large powers of a number greater than 1 become ever larger, while large powers of a quantity smaller than 1 become ever smaller, this form is indeterminate as it can go either way to any value, including of course 1 itself. According to the rule of number, 1 raised to any number is always equal to 1. But in differential calculus, 1 here is 1 does not have an exact value, no? Well, dili siya gyud 1. It just approached 1. Kaya may limit tayo eh. Tsaka it is raised to a very large number that we do not know the magnitude of that very large number. So the 1 raised to infinity is an indeterminate form of a number. Next form is infinity raised to 0. According to the rule of algebra, infinity raised to a number raised to 0 is always equal to 1 except for 0. Here, a very large number raised to 0 is an indeterminate form. Why? Because it represents the limit obtained by raising a large quantity to a small exponent. It is not necessarily 0. It just approaches 0. Since a small exponent makes the power of a large quantity smaller, base and exponent tend to opposite directions, so that this form can take any value depending on the relative size of base and exponent. Next is, the last one is 0 over 0. So this is one of indeterminate forms also. The form 0 over 0, 0 raised to 0 is indeterminate because it represents the limit obtained by raising a small quantity to a small exponent. Since a small exponent makes the power of a small quantity larger, base and exponent tend to opposite directions, so that this form can take any value depending on the relative size of base and exponent. So we just have to go back, no? You just have to familiarize yourself to these indeterminate forms. Pag evaluate nyo sa limit, pag ganyan yung lumabas, then that is one of the indeterminate forms. You cannot find the limit using the knowledge you have had today, no? Kasi by direct substitution lang yung ginagamit natin. But for this video, we will talk methods, we will discuss methods that will somehow evaluate a limit of a function that comes up first to an indeterminate form of a limit. So we'll have some okay, we will talk now some two functions. Let's just say this function y is equal to 1 plus the limit of 1 plus x raised to 1 over x as x approaches to 0. What we know so far is that by direct substitution, this limit is equal to, the limit of this one would be, you just have to substitute 0 here. That would be 1 plus 0, 1 over 0. And we know that 1 over 0, according to the law of balloons, that is infinity. So this one is equal to 1 raised to infinity. So therefore, limit of x 1 plus x raised to 1 over x as x approaches to 0 is 1 raised to infinity. And we know that this is one example of, this is in the indeterminate form. So by direct substitution, we cannot evaluate the value of we cannot evaluate the limit of this function just by direct substitution. So we need to employ some methods to get the limit of this function as x approaches 0. Now, what about this one? Let us say limit of all over t minus 2 minus 4 over t squared minus 4 as t approaches to 0. So we are attempting to find the limit of this function as t approaches to 0. Now, by direct substitution, as we based from the knowledge that we have already on the limits, just have to directly substitute value 0 here to this function to get the limit. So by direct substitution, the limit of this function 1 all over t squared, t minus 2 minus 4 over all over t squared minus 4 is equal to 1 over t minus 2 0 minus 2 minus 4 over 0 squared minus 4. And this is equal to negative 1/2 minus negative 4 minus 4 over negative 4. And that is equal to negative 1/2 minus 1, that is negative 3/2. So therefore the limit of 1 over t minus 2 minus 4 over t squared minus 4 as t approaches to 0 is equal to negative 3/2. Now, this is not not new to you, because you get a finite number, negative 3/2, meaning the limit of this function as t approaches to 0 has a finite limit, which is negative 3/2. Now, what if the limit of this function, now what if we try to evaluate the limit of this function as t approaches to 2? So, limit of 1 over t minus 2 minus 4 all over t squared minus 4 as t approaches to 2. So, by direct substitution, we have 1 minus 2, 1 all over t minus 2. So, that would be 1 over 2 minus 2, because t approaches to 2. So, you just have to substitute 2 here. 2 minus 2 minus minus 4 is 1, 4 all over t squared, that is 2 squared minus 4. So this is equal to 1 over 0, that would be infinity, 4 over 0 minus infinity. So therefore, limit of 1 over t minus 2 minus 4 over t squared minus 4 as t approaches to 2 is equal to infinity minus infinity. And again, this is an indeterminate form, infinity minus infinity, and we do not accept indeterminate forms. You need to determine the limit of this function as t approaches to 2. So we will discuss some of the methods that will evaluate the limit of a function if by direct substitution it will yield to an indeterminate form. Now let's start with the first method on determining the limit of a function that will yield to an indeterminate form. The first one is the factor and cancel method. I have checked your assignment and some of you have used this method already. Basically, this method, according to the slide, step 1 is just to factor numerator and denominator, and then step 2, cancel any common factors that may be revealed by factoring, and then step 3, compute the limit of the function obtained after cancelling. You just have to be reminded that if factoring is not possible, or if the new function produces another indeterminate form, a different method may be needed. So, pag dili pwede ma-factor ang numerator o denominator, then factor and cancel method is not the best, or it's not the fitting method to be used in determining the limit of the function. Let us have this example. Okay. Example, we will evaluate the limit of x cubed limit of x cubed minus 3x squared minus 3x plus 9 all over x squared minus 9 as x approaches to 3. Of course, our direct attack here is to is by direct substitution. So by direct substitution, limit of this function, I just have to substitute 3 cubed minus 3 times 3 squared minus 3 times 3 plus 9 over 3 squared minus 9. This is equal to 3 cubed is 27 minus 3 raised at 3 times multiplied to 3 squared, that is also 27 minus 9 plus 9 all over 9 minus 9. Eventually this is 0 over 0, and this is a form of, or this is an indeterminate form of a limit. Now the first method that we will discuss is the factor and cancel method. We will try to factor out the numerator and denominator and see if we can if there are factors that we can cancel, so that we may evaluate the new function that comes after factoring. So what are the factors of x cubed? So we have here limit of x cubed minus 3x squared minus 3x plus 9 all over x squared minus 9 as x approaches to 3. Now I'll just have to I'll just have to separately factor this on another piece of a paper. X cubed minus 3x squared minus 3x plus 9, okay, all over x squared minus 9. So basing from the knowledge you had already on factoring, on algebra, akong atake ani is I'll just have to group this one, and then this one also I'll group this, so that is equal to x cubed minus 3x squared minus 3x, this time it will be minus 9, so that negative times negative will equal to the positive value. Okay, next, this is x squared minus 9. So factoring out here x squared, I can say x squared is a common factor. So x squared, that and the remaining variable, the remaining term for this first function is x minus the remaining term for the second second term is 3. So that x cubed minus 3x squared minus the common factor of this function is 3x minus 3, and this one here is a difference of two squares. The factor of that is, I know you are quite familiar with x minus 3 and the conjugate x plus 3. So sa taas, common factor na naman yung x minus 3. So we have x squared minus 3, and then x minus 3 over x minus 3 x plus 3. Eventually, magka-cancel yung magka-cancel yung x minus 3. So, yung maiiwan na lang natin ay x squared minus 3 over x plus 3. So, therefore, this limit, so therefore, the limit of x cubed minus 3x squared minus 3x plus 9 all over x squared minus 9 as x approaches to 3 is just equal to the limit of what? X squared minus 3 over x plus 3 as x approaches to 3. And now we can readily substitute again 3 here. So this will be 3 squared minus 3 over 3 plus 3. And therefore that is equal to 3 squared 9 minus 3, that is 6 over 6. And that is equal to 1. So therefore, ang dating limit na nag-yield ng indeterminate form, nakuha na natin ang limit by using factor and cancel method. So therefore, the limit of x cubed minus 3x squared minus 3x plus 9 all over x squared minus 9 as x approaches to 3 is equal to is equal to 1. This is your final answer. Okay? So, nagamit natin ang factor and cancel method. Of course, kasi there is a common factor in the numerator and in the denominator. Now, let us try to have another example. What is the limit of x raised to negative 1 minus 0.25 all over 4 minus x as x approaches to 4. Again, by direct substitution, this is equal to 4 raised to negative 1 minus 0.25 over 4 minus 4. 4 raised to negative 1 is just equal to 0.25 minus 0.25 over 0. And this is equal to 0 over 0. Another indeterminate form of your limit. So we will try now to have we'll try to factor this function first. This one. So that would be x raised to negative 1 minus 0.25 over 4 minus x. This is equal to, of course, x raised to negative 1 is 1 over x. And I'll just have to convert them all to fractional form. And this is 4 minus x. Okay? Now, taking cube on this, I'll just have to combine this term. That would be, of course, your least common denominator is 4x. 4x divided x is 4 times 1, that is 4, minus 4x divided by 4, that is x, minus x, all over 4 minus x. Now question, can we cancel 4 minus x? Of course you can. 4 minus x is part of the numerator and 4 minus x here is part of the denominator. So you can cancel these 4 minus x's. Ang nabili na lang is ang nabilin kay 1 over 4x. So therefore, here, the limit of x raised to negative 1 minus 0.25 over 4 minus x as x approaches to 4 is equal to the limit of the resulting function after factoring 1 over 4x, the limit of 1 over 4x as x approaches to 4, and that is equal to, you just have to substitute 1 over 4 times 4, and it is 1 over 16. So therefore, the limit of this is equal to x raised to negative 1 or minus 0.25 all over 4 minus x as x approaches to 4 is equal to 1 over 16. Therefore, okay, I hope that you understood the factor and cancel method. So you just have to remember always, no, as I've mentioned already a while ago, na kung dili posible mag-factor, then we'll proceed to a different method of determining its limits. So we will now proceed to the next method of determining a limit. That would be by method of rationalizing. So the method of rationalizing, it is only applicable when the expression involves a sum of or difference of square roots. You can multiply and divide it by its conjugate and then use the difference of squares formula. Or if when the expression involves a sum or difference of cube roots, you can multiply and divide it by the appropriate sum required by the sum or difference of cubes formula. Always remember, the method of rationalizing does not eliminate roots. It only moves them to a different location in the expression and in a different form. It is useful only if the new form suits the required computations better. Also, the new version of the expression may differ from the original one in its domain, usually only for one value. So, in algebra, rationalizing means to multiply and divide it by a suitable factor so that the new version is easier to work with. The rationalizing is always applicable. Applicable at most times, no. Mostly applicable siya sa functions involving radical equations. And you need to multiply the numerator and the denominator by its conjugate. For example, we want to find the limit of square root of 4 minus x minus 2 as x approaches to all over x, as x approaches to 0. Now, in high school, in your senior high school years, you were taught to always rationalize the denominator, but in differential calculus, that case is not always applicable to denominator. It is also applicable to numerator. Our goal here is to transform the equation, the function, to a rather new one if the limit of the first equation or the limit of the function is will yield to indeterminate form. For example, this one, if we directly substitute the value of 0 here, as we tend to evaluate the limit of this function, that would be square root of 4 minus 0 minus 2 all over 0. And that would be equal to square root of 4 is 2 minus 2, 0 all over 0. That this is indeed in the limit of this indeed is in indeterminate form. So we will now employ the method of rationalizing by rationalizing the denominator. So we have this first term, this is our first term, and this is the second term. Multiplying that by the conjugate, we know that the conjugate of this is you just have to get the opposite sign of that. You retain the first and second terms, square root of 4 minus x and 2, that would be plus. This is the conjugate of this function. So I'll just have to work with the function first. I'll have to work with this function, square root of 4 minus x. So square root of 4 minus x minus 2 all over x. Now you multiply that one by the conjugate, square root of 4 minus x plus 2 all over x. We know already in algebra during your senior high school that this one, multiplying this one, is just in the form of a minus b and a plus b. The resulting product is a difference of 2, or the difference of 2 squares. So you just have to square this term and also this term, so that the resulting equation would be square root of 4 minus x squared, that would be 4 minus x minus 2 squared, that is 4 all over kailangan pala tong hindi pala dapat to x, it should be square root of 4 minus x plus 2. Why is that so? So that you did not alter your equation. This is just equal to 1, this overall term here. So multiplying now x, that would be x square root of 4 minus x plus 2x. So therefore, this limit, the limit of square root of 4x minus 2 all over x, is just equal to this. This is equal to 4 minus 4 is 0, so negative x all over x quantity square root of 4 minus x plus 2. And of course, employing again the factor and cancel method, x will be cancelled, so the remaining terms are, for the numerator, negative 1, and for the denominator, square root of 4 minus x plus 2. So therefore, the limit of square root of 4 minus x minus 2 all over x as x approaches to 0 is just equal to this one, limit of negative 1 all over square root of 4 minus x plus 2. as x approaches 0. Now substituting 0, that would be negative 1 all over square root of 4 minus 0 is 4 plus 2, and that would be square root of 4 minus 0 is 2, plus 2, that would be 4. So that would be minus 1 over 4. This is the limit of this function. Okay, we will have another example for method of rationalizing. And this time we will get the limit of cube root of x plus 1 and another plus 1 all over x squared minus 4 as x approaches to negative 2. Okay, so of course, by direct substitution, if we will substitute negative 2 here, this will be cube root of negative 2 plus 1 all over negative 2 quantity squared minus 4, and that is equal to cube root of negative 1 is negative 1 plus 1 all over negative 2 squared is 4 minus 4, and this is equal to 0 over 0, which is indeterminate. Okay, so indeterminate siya. The first limit by direct substitution, we get an indeterminate form of the limit, so we need to transform this somehow into another equation by employing method. This time, because we are on the method of rationalizing, we will use the method of rationalizing. So we'll just have to work first on this equation. We have to rationalize this first so that we will get the resulting equation before we will evaluate the limit. So to rationalize that equation, cube root of x plus 1 over x squared minus 4. Since we are dealing with cube root of x plus 1, we will make this into a cube, a difference of cubes. We know in algebra that the sum of cubes a cube plus b cube is just equal to a plus b quantity a squared minus ab plus b squared. So to rationalize the numerator, which is this one, cube root of x plus 1, so to rationalize that one, we let a is equal to cube root of x plus 1. We let a is equal to cube root of x plus 1. This is just to cancel basically the radical function at the numerator, because we are rationalizing the numerator, and b is equal to 1. So by that we have here square root of cube root of x plus 1 cube plus b, which is 1 cube is equal to a plus b cube root of x plus 1 plus 1. So cube root of x plus 1, which is our a, plus 1, which is our b, multiplied to a squared. Baka hindi magkasya, no? Multiplied to a cube root of x plus 1 squared minus a, which is cube root of x plus 1 multiplied to b, which is equal to 1. So we just have to retain cube root of x plus 1 plus b squared, which is equal to 1 squared, so that is 1. So therefore this one, as we this one, as we evaluate this one, that will yield to this one. This is equal to x plus 1. This one is equal to 1. So plus 1 again is equal to, this one is cube root of x plus 1 plus 1. This one is cube root of x plus 1 quantity squared minus cube root of x plus 1 plus 1. So therefore this is equal to x plus 2 and this is equal to this term. Okay, so this one we just have to multiply this one by what, so that it will have, the radical sign will here will be cancelled. Just have to multiply this one by this one. So kani mo ang i-multiply ani. You just have to multiply this by this one. Ito i-highlight. Kani. Just have to multiply this one so that your resulting equation will be x plus 2. This one is already here. Nani siya. So we just have to multiply this one by this one so that the equation will be equal to x plus 2. So multiply both parts of the numerator and denominator by cube root of x plus 1 quantity squared plus cube root of x plus 1. I'm sorry, this is minus plus 1. You know? Okay? Wala. So to not to alter the original equation, you just also copy this one at the denominator so that nothing changes in the original equation. Minus cube root of x plus 1 plus 1. So this one multiplied to kani nga term, multiplied ring nga term, according here is just equal to what? X plus 2. So this is equal to x plus 2 over quantity x squared minus 4, but x squared minus 4 can be factor also. That is difference of two squares, x plus 2 and x minus 2. And of course this term here, cube root of x plus 1 squared minus cube root of x plus 1 plus 1. Of course, you can cancel x plus 2. So the remaining terms are on the numerator 1. On the denominator, you have x minus 2. Quantity cube root of x plus 1 squared minus cube root of x plus 1 plus 1. So this is the resulting equation of this function. So this function, the resulting equation would be this one. Okay? So, as you can see, medyo naging complicated yung resulting equation. You just have to remind you that this one, the method of rationalizing does not eliminate roots. So it will not eliminate the radical function in the entirety. Although we may have eliminated or simplified the numerator, but the denominator seems to parang naging tawag dyan, komplikado yung denominator. It only moves them to a different location in the expression and in a different form. So yung radical function sa numerator bumaba sa denominator. It is useful only if the new form suits the required computations better. So this time we'll check if the method of rationalizing can be used here in determining the limits of a function whose first limit yields an indeterminate form. So we will now so we will now evaluate this limit. Therefore, limit of cube root of x plus 1 plus 1 over x squared minus 4 as x approaches to negative 2 is equal to the limit of one over quantity x plus 2, ito x minus 2 pala, multiply to cube root of x plus 1 squared plus cube root of x plus 1 plus 1 as x approaches to negative 2. So by substituting now, we have 1 over negative 2 minus 2 times cube root of negative 2 plus 1 is negative 1 squared plus, we just have to make this a bracket, kailangan tayo parenthesis sulod. So plus cube root of negative 2 plus 1, that is negative 1 plus 1. Simplifying, that would be 1 over negative 4, dito na lang speakers ha, simplifying, that is equal to negative 2 times negative 2 minus negative 2, that is negative 4, multiplied to cube root of cube root, this is 1 squared, this one will become 1, so cube root of 1 And of course, cube root of negative 1 is negative 1. So minus 1 plus 1. This is equal to 1 over negative 4 times cube root of 1 is 1 minus 1 plus 1. And that is equal to negative 1 over 4. So this is your limit of this function. Okay, there are other examples that will change our perspective, our understanding on method of rationalizing, especially during senior high school days. You were taught that method of rationalizing is effective in eliminating radical signs in the denominator, so that you only rationalize the denominator. Here in differential calculus, you can always rationalize the numerator, or you can also rationalize the denominator. Even if it is not in the fraction form, you may also use the method of rationalizing. Okay, another way of evaluating the limit of a function whose first limit by direct substitution yields an indeterminate form is by combining fractions and logarithms. So in combining fractions and logarithms, if the limit of f of x as x approaches to c takes the form infinity minus infinity as a difference of two fractions, both k over 0, where k is a real number, the function can be modified by combining two fractions into a single one through a common denominator. And after doing this, another method may be attempted to resolve the indeterminate form. Or if a limit of f of x as x approaches to c takes the form infinity minus infinity as a difference of two logarithms both approaching infinity, the function can be modified by combining both logarithms into one by using the formula or the property of logarithm ln of a minus ln of b is equal to ln of a plus, or ln of a over b. So after doing this, another method may be applied to compute the resulting limit. Okay, so we will now consider an example for combining fractions and logarithms. Say for example, we want to get the limit of x squared over x plus 2 plus 2x over x plus 2 as x approaches to negative 2. So by direct substitution again, this one is equal to negative 2 squared over negative 2 plus 2 plus 2 times negative 2 over negative 2 plus 2. And this is equal to 4 over 0 plus negative 4 over 0. And that is equal to infinity. Of course, this is minus because positive times negative. So minus 4 over 0 is still infinity. And this is indeterminate. So because that is indeterminate, we will now again employ another method by transforming this function into another function using combining fractions. So alam kong magaling na kayo mag-combine ng fractions. So I just have to focus first on this function by combining them. So x squared over x plus 2 plus 2x over x plus 2 is just equal to, okay, puro pala x plus 2, ano? So the least common denominator is x plus 2, and then that would be x squared plus 2x. Okay. X squared plus 2x. Okay, so this one is the that is the defining or the function na naging that is the resulting function after we combine these two fractions. Okay, so by that the limit of ano ba yun? X squared over x plus 2 plus 2x over x plus 2 as x approaches to negative 2 is just equal to the limit of what? X squared plus 2x, x squared plus 2x over x plus 2 as x approaches to negative 2. Okay, so again, employing another pwede pa pala ito ma-factor out yung x. Balikan natin to. So this is equal to x, factor out x. The remaining function here would be x because x times x is x squared plus 2 over x plus 2. Oo nga, pwede pa. So makancel yung x plus 2. Ang maiiwan is x na lang. So this one is basically ito, delete natin daw. Okay. So this limit x squared over x plus 2 plus 2x all over x plus 2 as x approaches to 2 is just equal to the limit of x as x approaches to negative 2. And that would be equal to negative 2. Take note because we are simplifying the fraction, this fraction, the domain of this is not equal to the domain of this. But the limit of this one and the limit of this one is just equal. We are just simplifying them by combining fractions, but in conversely they are not equivalent functions. Just take note of that. This function is not equivalent to this function, but rather they have equal limits. We just have transformed this one by employing method of combining fractions to get the limit after the first limit of that by direct substitution yield a indeterminate form of its limit. Okay, we will consider another example. This one by the logarithm. We will find the limit of ln of x plus 3 minus ln of 2x minus 5 as x approaches to infinity. Okay, so of course ln of, we know in limits and continuities part 1 that the logarithm ln of infinity is just equal to infinity. So if you just substitute here infinity to x, that x infinity plus 3 or is a relatively large number plus a value 3 would be equal to a relatively large number, and ln of a relatively large number according here is infinity. So this is infinity, and this one would be infinity also. So minus infinity. And this is indeterminate. So focusing on this function, we have ln of x plus 3 minus ln of 2x minus 5. So by the rule of according to the one that we have discussed a while ago, that we know that ln of a minus ln of b is equal to ln of a minus b. This one. So according here, ln of a, this one, according here, ln of a minus ln of b is equal to ln of a over all over b. And this is also true to the logarithmic properties that you have already learned in your senior high school days. So ln of x plus 3 minus ln of 2x minus 5 is just equal to what? Ln of x plus 3 over 2x minus 5. And we know in logarithm na dito, so therefore this limit of ln of x plus 3, limit of ln of x plus 3 minus ln of 2x minus 5 as x approaches to infinity is just equal to what? Limit of ln of x plus 3 over 2x minus 5 according here as x approaches to infinity. So we will take note of the law of Jungle. We will divide both numerator and denominator by the highest term, which is x. So that would be this one. I'll just have to focus on this function first. Okay, so x plus 3 over 2x minus 5, you divide both terms by 1, or you multiply both terms by 1 over x. This will yield to what? X times 1 over x, that would be 1, plus 3 over x, and 2x times 1 over x, that would be 2, minus 5 over x, and that is equal to, so therefore this is equal to limit of ln of what? X and x, or 1 plus 3 over x according here, all over 2 minus 5 over x as x approaches to infinity. So substituting, that would be, that is equal to ln of what? 1 plus 3 over infinity over 2 minus 5 over infinity. And the limit of this 3 over infinity is 0 and 5 over infinity is 0 according to the law of balloons. So ln of what? 1/2 na lang. Or according to balikan natin yung ito. Balikan natin yan. This property ln of a minus ln of b is equal to ln of a all over b. If your a is 1 and b is 2. So if your a is 1, yan, Therefore, according to this one, your A is 1 and B is 2. Therefore, you can rewrite your final answer to ln of what? 1 minus ln of 2, or ln of 1 is 0, so your final answer is negative ln of 2. Okay, so that is your limit of this function. Okay, so another method of or another property, no, to be used in evaluating a limit, especially to trigonometric limits, whose first evaluation of the limit yields a indeterminate form. These basic trigonometric limits can be helpful in evaluating the limit of the function that is in terms of trigonometry. So the first one is limit of sine x all over x as x approaches to 0 is equal to 1. This is a technical fact, and it was proven through mathematics. If you want to read the proof, that was in the lecture module that I have uploaded in the Google Classroom. And the second technical fact, that is on the cosine aspect. Take note that the limit is the x is approaching to 0. Limit of cosine x minus 1 all over x as x approaches to 0 is equal to 0. So you just have to familiarize yourself with these trigonometric limits, and you may apply this one to certain functions that involve trigonometry. Later on we will have some examples for that. So I suggest also that you should always familiarize the trigonometric properties, especially those who have not yet encountered the trigonometric properties, so that you may be able to solve the transformed functions using trigonometric properties. Okay, now so using these two technical facts, the limit of sine of x as all over x as x approaches to 0 is equal to 1, and the other one is limit of cosine x minus 1 all over x as x approaches to 0 is equal to 0. We will now solve problems or limits that involves trigonometric properties, so that we may be able to use this one in evaluating the limits of the function, involving trigonometric identities. Okay, so this time we will try to solve the limit of sine 3x over sine 4x as x approaches to 0. Make sure if you are evaluating limits of in angular form, make sure that you always express your answers in radian form, so meaning in terms of pi, not in terms of degrees. So I'll just have to isolate this function before we will of course, by direct substitution, you know that sine of 3 times x 0 over sine of 0. Of course, you cannot directly eliminate sine 0 and sine 0 here, because sine 0 is 0 and sine 0 is 0. This is indeterminate. So indeterminate in nature. So what we will do now is taking use of these trigonometric limits, limit of sine x all over x as x approaches to 0 is equal to 1. Nagsatisfy naman po yung approach natin, x approaches 0. So by using the property sin 3x, dito na talaga, I'll just have to isolate this one first. Ito, paano ba yan? Sin 3x. Okay, paano ba natin ita-transform yan into this one? Ito yung forma niya, sin x over x. So ganito yan, sin 3x is just equal to kalimutan ko yung denominator, sin 3x over sin 4x. Okay, so I will multiply both parts of the equation, both numerator and denominator, by 1 over x, so that it will become this function will become sin 3x over x and sin 4x over x. Question: have I changed the original function? No, because you just only multiply a function that is equal to 1. Okay? Now, ang sabi dun sa dito sa technical fact, dapat pareho yung coefficient niya, 1 at saka 1. Dito sa ating example, 3 siya diba? 3, dapat may 3 din dito, so lagyan natin ng 3 dito at saka 3 dito. So therefore sin 3x over x all over sin 4x over x. Yan, ito yan siya. Again, multiply na naman ako sa numerator, both numerator and denominator of the numerator, with 3 over 3. Of course, yung minultiply ko 1 lang din. Tsaka the same sa denominator, multiply it by 4 and 4, so that the resulting function would be 3 sin 3x over 3x all over 4 sin 4x over 4x. So this is equal now to this limit of x approaching to 0, limit of sin 3x over sin 4x as x approaches to 0 is just equal to limit of 3 here sin 3x over 3x all over, dapat nasa gitna yung limit, for sin 4x over 4x as x approaches to 0. Of course, we have an identity here of the limits, property of a limit. According to the property of a limit, if c is a constant value, c limit of according to the property, if limit of c f of x as x approaches to a function, a certain value k, whether finite or infinite, this is just equal to what? Because c is a constant value, you can get that out from the limit sign. So c limit of f of x as x approaches to k. So the same thing will happen here. We have a constant here, 3 and 4. Just have to this is equal now to limit of what? Limit of 3, limit of sine 3x over 3x as x approaches to 0 all over 4, limit of sine 4x over 4x as x approaches to 0. Ito po yung ginawa ko. Nilabas ko siya sa limit sign. And of course, according to another limit, rule of limit, pwede mo siyang i-distribute sa numerator and denominator. So that this is equal to, of course, according to our technical fact, that would be equal to 1. So this one is equal to 1. The limit of sine 3x all over 3x as x approaches to 0. So this would be 3 times 1. This one is also equal to 1 as long as this one and this one are the same. So 4 over 1. And that is equal to 3 over 4. So the limit of this one, the limit of sine 3x all over sine 4x as x approaches to 0 is equal to 3 over 4. Okay. What about on the part of cosine? We'll have hindi pala nakita yun ano. Yun. Balikan ko Yun. 3 limit of sine 3x all over 3x as x approaches to 0. We know that this term is equal to 1. So 3 times 1. And we know also that this term, including the limit, is equal to 1 in regards to this technical fact. So 3 times 1 all over 4 times 1, that is equal to 3/4. Now we'll have another example. This time in terms of cosine naman. And we'll adapt some trigonometric identities that you have learned during your senior high school days. Now, let's try this one. Limit of limit of sine x over x minus pi. Kala ko cosine. Wala pala akong cosine. Ano? Okay, let's just have this one. Limit of sine x all over x minus pi as x approaches to pi. Now, by direct substitution, we have sine pi over pi minus pi. We know that sine pi is a teacher, 0. Pi minus pi is 0. And this is indeterminate. Okay, so we will now try to focus on this one by transforming that into one of these technical facts, sine x all over x. Now, how can we do that? Okay, so dito ako magpo-focus sine x all over x minus pi. Just have to transform that one into a sine x over x na format. So sine x over x minus pi. So magiging sine x minus pi plus pi. Bale, ang in-add ko lang is 0. So bale, itong term na to is equivalent to sine x. Okay? Sine x minus pi plus pi all over x minus pi. Of course, para maging tawag dyan, we will introduce dummy variable, let us say z, no? We will introduce a dummy variable, let us say z. So z is equal to x minus pi, and that pi is equal to, paano ba? Pi is equal to x minus z. Pwede na yung pi dun. So x minus pi. Okay. So this will be equal to, so sine, ano to? Sine, this one is equal to, ito is equal to z, including this z. So magiging sine z plus pi over this one is x minus pi is z. We know the sine law, no? Sin cos cosine. Alam niyo yan. This is equal to sine z cosine pi. Pag sine, dapat retain mo yung positive. So sin cos cosine z sine pi. Sine pi is 0, so this one is definitely equal to 0. Yun. All over z. Of course, cosine pi is equal to what? Cosine pi is equal to negative 1. So magiging negative sine z over z. So parang naging katumbas na, parang naging ganito na ano yung itsura niya, ganyan na. Now because we are changing the variable, because we are changing the variable, we need to change also the approach of your limit. So iban ko lang ha, yung limit mo originally is from yun, limit of sine x all over x minus pi, that to be limit of sine x minus pi as x approaches to pi. Nag-introduce ka ng dummy variable na z is equal to x minus pi. So kung nag-introduce ka ng dummy variable na z, dapat yung approach mo dito, pag i-change mo yung variable mo dito ng z, i-change mo din itong variable mo dito ng z. And of course, your corresponding approach here ng pi. So if your x is approaching pi minus pi, your z will approach to what? 0. Such that this is equal to limit of sine, ito, in terms of z na siya. So sine z negative over z as what? Z approaches to 0. Sir, paano kung x pa rin dito? Mali. No? Wala kang i-determine na limit. Nag-introduce ka ng bagong variable z. Dapat you should always consider also the other variables included in your limit function. So again, may negative ka dito. That would be negative limit of sine z over z as z approaches to 0. This one, ito, swak to siya dito na yan. Diyan na, dito na technical fact. So dahil swak siya dyan, then this one will be equal to what? Ito, this is equal to 1 according to technical fact. So negative times 1, that would be the limit of this one, sine x all over x minus pi is what? Negative 1. So ito yung answer mo. Okay? So the limit of sine x all over x minus pi as x approaches to pi is just equal to limit of negative sine z over z as z approaches to 0, where z is equal to x minus pi, and that is equal to negative 1. So we are now down to two methods. So these are the limits of transcendental functions. We have here the strategy for handling limits involving transcendental functions. So when analyzing algebraically a limit that involves transcendental functions, you need to check for special features of those functions that can lead to a conclusion. For example, for ln, you need to check on ln whether the natural logarithm, what could be the special features of these functions that can lead to a conclusion on the limit. In particular, we consider using any identities or special discontinuities, as well as information about limits at infinity. The last one is the limits of parametric and polar curves. So we have the strategy in identifying first the strategy for interpreting limits in a parametric curve. So in order to classify the graphical features of the parametric curve by using limits, we need to look simultaneously at limits generated by the two coordinates for the value of t in question. It is not just t. We also it is a parametric curve. So in terms of t, we have this technical fact: a parametric curve x of t and y of t has a single point hole for t is equal to c if at least one of x of c and y of c does not exist, and both limit of x of t as t approaches to c is equal to a, and the limit of y of t as t approaches to c is equal to b are finite. In such case, the hole is that the point AB. And the strategy for interpreting limits on parametric, or strategy for identifying asymptotes in a parametric curve. So to identify the vertical asymptote of x of t and y of t, identify all values for which limit of y of t as t approaches to a is equal to positive or negative infinity, even if from one side only. And for each value, if limit of x of t is equal as t approaches to a is equal to c for a finite value c, then x is equal to c is a vertical asymptote. So to identify a horizontal asymptote of the parametric curve x of t and y of t, we need to identify all values for which a limit of x of t as t approaches to a is equal to positive or negative infinity, even from one side only. For each such value, if a limit of y of t as t approaches to a is equal to c as a finite value, then y is equal to c is a horizontal asymptote. I have checked your assignment number 2, and the number 4 is considered to be a bonus because that is in terms of a polar curve, and we did not tackle yet, we did not discuss yet the vertical and horizontal asymptotes of the polar curves. Okay, so we'll now solve some one example for transcendental limits. This involves some trigonometric functions. For example, you want to solve the limit of sine x plus cosine x over cosine 2x as x approaches to negative pi over 4. So by direct substitution, you have here sine of negative pi over 4 and cosine negative pi over 4 over cosine 2 times negative pi over 4, and that is equal to sine negative pi over 4 is square root of 2 over 2, and cosine negative pi over 4 is square root of 2 over 2. Oh yeah, this is plus plus pa pala dito. Okay. So, sine negative pi over 4 is negative square root of 2 over 2 plus cosine negative pi over 4 is positive square root of 2 over 2 or 0.71. Cosine 2 times negative pi over 4 or cosine negative pi over 2, that is 0. So this is equal now to 0 over 0, which is indeterminate. So focusing now on this equation, we will transform this function. We say that transcendental because it is more complicated portion, or it is more complicated function. We will try to transform this one to another function so that the resulting function, we can get the limit in the resulting function nga unta dili siya indeterminate. So the function is sin x plus cosine x over cosine 2x. Now recall some trigonometric properties from your algebra. What can you say, or unsa ba ang iyong technique so that this equation will transform into another equation, no? Let us say we will multiply this one by cosine x minus sin x, no? Just multiply this one by cosine x minus sin x over cosine x minus sin x. Okay, so I've said, if you will multiply something to a function, make sure that the function remains the same. Nothing has been changed. You did not alter the original function. So you just multiplied basically 1 here in the form of cosine x minus sin x all over cosine x minus sin x. Now multiplying this thing here, this one and this one, this one and this one, it will yield to a difference of 2 squares. So cosine squared x minus sine squared x over cosine 2x multiplied to cosine x minus sin x. Okay. Now, what is the trigonometric identity of cosine 2x? Recall that cosine 2x is just equal to what? Cosine squared x minus sin x. We know in trigonometry that cosine 2x is equal to cosine squared x minus sin squared x. This is what? Double angle formula. Double angle formula. For sin 2x, that is equal to 2 sin x cos x. Another double angle formula. You just have to recall your trigonometric properties. Double angle formula and the half angle formulas. So here, this one will become cosine squared x minus sin squared x. This is this form, this function, and the numerator. You divide it by, we know already that this trigonometric function is equal to this function, cosine squared x minus sine squared x multiplied to, of course, this one, cosine x minus sine x. So this is equal to, this one will cancel, and that will be equal to 1 over cosine x minus sine x. So therefore, the limit of sine x plus cosine x over what? Cosine 2x as x approaches to negative pi over 4 is just equal to what? Limit of this one, the transform equation, a function, 1 over cosine x minus sine x as x approaches to negative pi over 4. Now you just substitute. That would be 1 over cosine pi over 4, negative pi over 4, minus sine of negative pi over 4. Excuse me. And this is equal to 1 over, we know that cosine negative pi over 4 is equal to positive square root of 2 over 2 minus, we know that sine negative pi over 4 is negative pi over 2, negative square root of 2 over 2, so minus negative square root of 2 over 2, and this is equal to 1 over square root of 2 plus square root of 2 all over 2, that would be square root of 2. To simply put, that is equal to square root of 2 over 2. So pag hindi kaya ng factor and cancel method, pag hindi kaya ng method of rationalizing, pag hindi rin kaya ng ano pa ba, hindi kaya ng combining fractions and combining logarithms, then posibleng transcendental functions ang iyong na-encounter. So you must make use of some properties in algebra, trigonometric properties, and logarithmic properties. Okay, so that ends our video lecture for limits and continuities part 2. Thank you. Maraming salamat po sa pakikinig at pag tingin ng video na to. And hopefully you get some you learned in the evaluating limits, such that the first limit yields to an indeterminate form of limit. So these are my resources, the robertosmathnotes.com. It was retrieved last August 2021. Of course, the textbook that we used, Love and Rainville, 1962, 4th edition. Prater-Murray and Prater-Phillips, Calculus with Analytic Geometry, 4th edition. And big thanks also to credits to FreePic and SlidesGo, Flaticon, for this PowerPoint presentation that I was using. So thank you, and we'll see you again next time.